Hi everyone, this is Dr. Webster, and this video is going to cover conducting a within subjects one-way ANOVA, or you can say one-way within subjects ANOVA, that's fine. Another name for this is a repeated measures one-way ANOVA. Either way, I am going to redo the lecture example looking at differences in prejudice towards prostitutes, feminists, and lesbians. And so here I have real data from another published study looking at how political orientation predicts different types of prejudices. And so, yeah, so let's get started here. And we're doing a one-way within subjects ANOVA because we have one sample, right? One sample providing three different outcomes here, right? Prejudice towards prostitutes, prejudice towards feminists, and prejudice towards lesbians, right? All predominantly female groups, right? Marginalized groups historically. So, yeah. So let's go to general linear model, and then go to repeated measures. And then we will start with naming our within subject factor name. And so what we're really looking at is, prejudices towards different social groups. And so that's what I'm going to name my within the subject's factor. Just going to name it social group because we have different social groups, right? Feminists, prostitutes, lesbians. And there are three, right? Three different groups. So number of levels will be 3. If you remember, so that towards the beginning of the semester when we talked about in terms of counting the number of categories or something, sometimes levels is used. In this case, levels refer to the number of outcomes that we're looking at. And then we will click Add, and then we'll click Define. And then you can see question marks here for the 3 different outcomes. And so we're going to move prejudice towards feminists, prejudice towards prostitutes, and prejudice towards lesbians over to the within subjects variables box. All right. The order of these is completely arbitrary. I am just entering them based upon the order that they appear in the data set. And I believe this is the order that they appear in the lecture slides. So yeah, just going to keep this order. And then next, we would like to go to EM means, and you'll get this little box that pops up, and we want to bring our within subjects factor over social groups. We'll say display means for, we'll click compare main effects, and then we will select Bonferroni. So this is just seems like a laborious process in order to get our post hoc tests, our post hoc Bonferroni tests, to see which groups significantly differ if the overall ANOVA or omnibus table has a significant p-value. So we'll click continue, and then we'll click save. And just like for the between subjects, one-way ANOVA, we'll ask for Cook's distance value. So we want to check those values before we check out the output. So we'll hit continue, and under options, we'll click again under options, descriptive statistics, estimate of effect size, and homogeneity tests. We'll click continue, and we will click paste. And here we are with our syntax to run our one-way within subjects ANOVA. And so I'm going to highlight and then run the selection. And then we get our output, and we get a lot more tables than we actually looked at in class in the lecture slides. So we are going to delete some of these right off the bat. So The multivariate test table, we are just going to delete. And then there's this table called test within subjects contrasts. We don't need that for our purposes. We're going to delete that too. The test of between subjects effects table, we delete that too. Where it says estimates, we're also going to delete that too. And then there's another multivariate test table down at the bottom. We're going to delete that too. So we're going to be left with the table that provides the numerical codes for each of our outcomes. So 1 is feminist prejudice, 2 is prostitute prejudice, 3 is lesbian prejudice. We have our table of descriptive statistics, and so I'll change this to 2 decimal places, a bit easier to look at. We have our test of sphericity, which we'll take a look at in a second, and then we have our ANOVA omnibus table, ANOVA or omnibus table, or test of within subjects table. We'll come back to that, and then we have our post hoc table. SPSS calls it here, pairwise comparisons. They should just use consistent terminology, regardless of the ANOVA. So pairwise comparisons, multiple comparisons, post hoc test, virtually talking about the same thing. The very first thing that we want to do, though, is go back and make sure our Cook's D values look okay. Sorry, I had some extra Cook's D variables there, so I wanted to just have the Cook's D variables that were created from running the syntax that we just ran. And so you'll notice that we get 3 Cook's D variables in our data set. So SPSS just created 3 Cook's D variables in our data set because we have 3 different outcomes. We have prejudice towards prostitutes, prejudice towards feminists, and prejudice towards lesbians. So each of these gets their own Cook's D variable. And so we'll have to sort these descending highest to lowest and check for any big jumps. And so sort the first variable here, descending, everything looks good, nice gradual decrease. Sort number 2 here, descending. So we have maybe a little bit of a jump from 0.09 to 0.05, but just in my experience, I know that is not going to make a big deal. I would be more concerned if that was more like 0.15 or 0.2. I just know from experience that this seems like a larger jump to 0.04 to 0.01, but I'm not really that troubled by that. And then for the third outcome here, we sort descending, and we see a nice gradual decrease. So the Cook's D values all look okay. There don't seem to be any suspicious participants, any potential outliers here for the analysis. So we can go back to the output, and we'll take a look at Mockley's tests of sphericity. Well, actually, let's take a look at the descriptive statistics first. I was just thinking about the order we did things in lecture, and let's do the descriptive statistics first. Let's just take a look at the mean prejudice scores here for feminists, prostitutes, and lesbians to get a sense of what's going on. When we did the paired sample t-test, when we were just comparing prejudice towards feminists and prejudice towards prostitutes, we found that people reported a lot more prejudice towards prostitutes compared to feminists. Right, we already know that from the paired sample t-test. We're most interested here to see how people score in terms of prejudice towards lesbians. How does prejudice towards lesbians compare to prejudice towards prostitutes and prejudice towards feminists? And we see that the mean score for prejudice towards lesbians, 4.22, which is way lower than prejudice towards prostitutes and a little bit lower than prejudice towards feminists. So if we observed a significant difference in the paired sample t-test comparing prejudice toward feminists and prejudice toward prostitutes, we should definitely see a difference here in terms of people reporting more prejudice towards prostitutes compared to lesbians. But it'll be interesting to see if this is a significant difference in comparing prejudice towards feminists and prejudice towards lesbians, 4.76 to 4.22. Is that going to be a large enough difference? Is this difference going to be far enough away from zero to indicate a true and real difference? Well, we will find out. Right, so it definitely seems like people are still reporting more prejudice towards prostitutes compared to feminists and lesbians, and then we'll see if there's a difference between prejudice towards feminists and prejudice towards lesbians. So before we take a look at the ANOVA or omnibus table here, we need to take a look at Mauchly's test of sphericity, which is similar to Levine's test for equality of variances, which applies to the independent sample t-test and the between subjects ANOVA. So sphericity is for the within subjects ANOVA only. And so we take a look at the sig value or p-value for Mauchly's test. We want Mauchly's test to be non-significant. We see the p-value here of 0.014. Unfortunately, Mauchly's test is significant. So that, depending on whether Mauchly's test is significant or not, that will change the row that we look at down here in the ANOVA or omnibus table. And as I explained in class, Mauchly's test tends to be a lot more significant, or I should say it tends to be more significant more often, or should I say it tends to be significant more often or more frequently than Levine's test. It's very sensitive to bigger samples, and so we know that with bigger samples, we're more prone to get significant p-values, and so Mauchly's test is very sensitive to sample size. But in any case, Mauchly's test is significant. That means down here in the ANOVA or within subjects effects table, that means we are going to use the greenhouse geyser row to pull all our numbers from. All right. If Mauchly's test was non-significant, then we would use the sphericity assumed row. All right. And I am just going to, again, make the relevant numbers to decimal places. It'll just be easy for us to read. Select all those. Bam. Just a little bit easier to look at here. So we're looking in the greenhouse geyser row because Mauchly's test is significant. So we have our degrees of freedom between and within, and you'll notice that we actually have decimals for our degrees of freedom. That is just how the greenhouse geyser correction works. We have decimals for degrees of freedom. It's unusual. It's the first time that we're seeing this, but this is how we'll report it. Once we get to if you were writing this up, we would see the italicized F, and then in parentheses we would put 1.88 comma 248.28, and that's a big sign that we're doing a one-way within subjects ANOVA, and we're using the greenhouse geyser correction. It's one of the only times that you'll see decimals and degrees of freedom. So degrees of freedom between, within, and then we have our inferential value, our F value. Remember, ANOVA uses F values as their inferential value. So we have our inferential value here, 53.13, and then using the degrees of freedom and the F value, SPSS finds the P value for the ANOVA or omnibus test here. And so this P value here is telling us whether there's anything worth looking at. Right, we are looking at differences between three groups, which means that we are now have to worry about three different comparisons or differences. And so SPSS is evaluating the differences between all the groups and then saying, is there a significant difference anywhere between the groups? And our p-value here is less than 0.001. It's significant, so that means there's at least one significant difference between the groups. And that should not come as a surprise because when we did the paired sample t-test, we know that people reported significantly more, a lot more prejudice towards prostitutes than they did feminists. So we should replicate that difference here in the within subjects ANOVA. We're more interested to see how prejudice toward lesbians compares to the other two outcomes here. And then we have our partial eta squared value, which is the effect size for our within subjects factor, in this case, social group. So how much does the type of social group, how much does the type of social group explain in terms of the differences in prejudice? How much does it matter? How much does the social group matter in terms of people reporting prejudice? And so we interpret the partial eta squared here just like we did for the between subjects one-way ANOVA. So we're going to use the same guidelines that we used. And so I'm going to just bring those up quickly here. So for partial eta squared, guidelines, small is less than 0.06, medium is 0.06 to 0.14, and then large is greater than 0.14. And so our partial eta squared is, in this case, 0.287. So we have a large percentage. So the social group actually explains a lot of the differences in prejudice, that the social group seems to matter a lot in terms of how much prejudice people are reporting. So the type of social group is explaining 28.7% of the differences or variability in prejudice, and that's a large percentage. So we know there's at least one significant difference somewhere, and in order to find out which groups, which outcomes, I should say, significantly differ, we need to look at the post hoc table or pairwise comparisons table down here. And again, I'm going to round to 2 decimal places for us, so it's a little bit easier to look at and calculate Cohen's d eventually. And just like for the post hoc table for the between subjects one-way ANOVA, we have redundant information in this table. And we also have to remember what 1, 2, and 3 here mean. I don't know why SPSS can't just put 1, 2, and 3 mean. But again, to remind ourselves, 1 is feminist prejudice, 2 is prostitute prejudice, 3 is lesbian prejudice. So we look at 1 versus 2, and so that is feminist prejudice versus prejudice towards prostitutes. And we see that we have a significant difference between feminist prejudice and prostitute prejudice, just as we found for the paired sample t-test. We're more interested to see how prejudice toward lesbians compares to the other 2 outcomes here. And so we have 1 versus 3, which is next. 1 versus 3. So this is prostitutes, prejudice towards feminists versus prejudice towards lesbians, 1 versus 3. And we see 1 versus 3, go over here, we take a look at the significance. The p-value is 0.02, and 0.02 is a significant p-value. Right, p-values are significant if they're less than or equal to 0.05. So we have a significant difference between prejudice toward feminists and prejudice toward lesbians, right? So this difference is big enough, far enough away from 0 to indicate a true and real difference. We are confident enough. 98% confident, technically. And then we have 2 versus 3. So this is prejudice towards prostitutes versus prejudice toward lesbians, 2 versus 3. And we see a significant p-value. So there is a significant difference in the amount of prejudice people are reporting towards prostitutes compared to lesbians. So people are reporting significantly more prejudice towards prostitutes compared to lesbians. People are reporting significantly more prejudice towards prostitutes compared to feminists. And people also reported more prejudice towards feminists compared to lesbians. But significance does not equal importance. And I am assuming that the difference between feminists and lesbians here, that's going to be maybe a smaller d value. Won't be as big as the d values looking at the comparisons. Looking at prejudice towards prostitutes versus feminists and prostitutes towards lesbians. So let's take a look at the d-values, and we'll go back to the test of within subjects effects table here, and this is where we'll get our S pooled. So to calculate our d-values, we need to take each mean difference, divide by S pooled, the pooled standard deviation, because we have 3 different outcomes, 3 different standard deviations, and we need to calculate the average standard deviation here. Technically, you could just add these up, divide by 3, and we should get the average standard deviation because the ends are all the same. but I think it's easier just to take the square root of the mean square error term. So mean square error term, mean square error term here. We see we're using the greenhouse geyser rho because Mauchly's test was significant. So we have 3.02. So taking the square root of 3.02, that will give us our S pooled value, 3.02. And the pooled standard deviation is 1.73. 1.73. 1.73. Just repeated it to myself so I remember. So we're going to take each mean difference here that we see down here, and then we're going to divide it by 1.73 in order to get our D values. 1.73. 1.73. It's 1.73. So I'm going to try to just make a note down here as we go through. D feminists versus prostitutes. Maybe I'll just spell them out first. D, I think it was feminists, or the prostitutes versus lesbians. And then we have the D for feminists versus lesbians. So 1 is feminist prejudice, 2 is prostitute prejudice, 3 is lesbian prejudice. So 1 versus 2, feminists versus prostitutes. So we're going to take 1.51. Again, we're not worrying about negative, positive signs right now. We'll worry about that for the write-up. So 1.51 divided by 1.73. So we get a D value of 0.87. So that's 1 versus 2. 1 versus 2. 0.87. And then prostitute. So this is, this will be D fem versus lesbians. So 1 versus 3. And then finally, prostitutes versus lesbians. Messed up the order there. That's why it's so confusing. I don't know why they just can't name these for us. So prostitutes versus lesbian 3. Okay, so now we have 1 versus 3, so that's 0.55 divided by 1.73. And I just realized I rounded incorrectly. I rounded incorrectly for the mean square error. I said 1.73, and then I just had this epiphany that I was like, I think I rounded incorrectly. It should be 1.74. So the mean square, messing up in real time here. So the mean square error, that was 3.02. 3.02. And the square root of 3.02 is 1.737, so that should be 1.74. So we should be dividing each mean difference by 1.74. So don't know if, so Duchess caught that. I know, Duchess. I messed up. Just talk to my bird. I know. Shh, shh. Let me finish. I know. All right, so 1.74, 1.74. Messed up here. So we'll redo 1.51 divided by 1.74. Is 0.87, still 0.87, and then 0.55, so 1 versus 3, divided by 1.74, we get 0.32, making sure, 0.32. And then we have the D for 2 versus 3, so that's 2.06. divided by 1.74, and that'll give us 1.18. And there we go. There's our D values for each of our comparisons. 0.87 and 1.18, those are both very large D values. So those are large differences. So people are reporting significantly more prejudice towards prostitutes compared to feminists and lesbians, and those differences are big, right? So people are reporting a lot more prejudice towards prostitutes compared to feminists, and a lot more prejudice towards prostitutes compared to lesbians. But the D value for feminists versus lesbians, there's a significant difference, but that difference is small. So people are reporting slightly more prejudice towards feminists compared to lesbians. Right, if you look just back at the mean scores, right, so looking at feminist prejudice, lesbian prejudice, right, people are reporting slightly more prejudice towards, slightly more prejudice towards feminists compared to lesbians. Sorry if I misspoke there. So people are reporting slightly more prejudice, somewhat more prejudice towards feminists compared to lesbians. So that is conducting, interpreting a one-way within subjects ANOVA. And we are coming up towards the 26-minute mark, so we will definitely end here. Thank you for listening.